In reality, you don't always have the theoretical yield. Why? You don't have complete conversions. You sometimes have side reactions, or you'll have, impurities in your starting materials that result in not getting the theoretical yield. Or your technique, you'll lose some of your product. I mean, you guys have enough lab experience to see that even when you follow a protocol or a recipe, it doesn't always turn out perfect, right? There's not always complete conversions. In fact, that's always difficult to get the theoretical yield, right? So what we're going to do is we have to figure out through stoichiometry, right, what the theoretical yield is. And I always say theoretical is the perfect world, right? It's like what's on paper, so not everything follows the blueprint perfectly. What you actually recover in lab, what you actually produce in a manufacturing setting is what's called actual yield, right? So there's a difference. And typically the actual yield is lower than the theoretical yield. So the efficiency of your reaction or your technique is based on a calculation called percent yield, right?
I feel like we did something like this when we did the sand. It was like
it was
our
percent
first lab.
recovery. That was percent recovery. We didn't produce anything. So we didn't actually make a product, but you're right that we started with material, we went through techniques and we try to recover it. But it does show you that did you recover everything? No.
It's either you recovered too much or not enough.
Well, no, we didn't recover too much. What it was either contaminated with something or it was still wet.
Oh, true, yeah.
So that's why your percent recovery would be over 100. So this is a little bit different. It's not a recovery, it's a yield. We're producing it. So like if you're a corporation, let's say you're a pharmaceutical industry and you're making a cholesterol drug. One of the things you want to do is you want to be efficient because you want to maximize your product. So you want to have the highest percent yield possible. So if you're getting percent yields of 20%, you're losing a ton of product, and that's not good for business and that's not good for dollars. So you're going to either have to improve your technique or make a better recipe or get pure samples. So it's a measure of how good either their workers are, their recipe, their instrumentation. But how do we measure it? It's percent yield. So how do you do that? Actual over theoretical times 100. Part over whole times 100. So here we have an example, right? It gets a little tricky here, right? So when 11.5 grams of carbon are allowed to react with 114.5 grams of copper 1 oxide. So what is that telling me? They're giving me both amounts of reactants. This is what type of stoich? Is it single or double?
Double stoich.
It's double. They're telling me I take both of these amounts, but I obtain this much. So this is my actual yield in lab. They want to know what is my percent yield. What do I need to figure out percent? Percent is actual over theoretical. They give me what I actually obtained. What do I need to figure out? My theoretical, the paper. And how do I do the theoretical? I have to do a what?
Double stoich.
Double stoich, and the theoretical yield is going to be the smaller amount.
The limiting reactant.
Yeah. So I'm going to go 11.5 grams of carbon, right? And 114.5 grams of copper 1 oxide. And I'm going to convert those to what? Well, what is the actual yield that I'm looking at? Of copper. So I need to convert both carbon and the copper 1 oxide to grams of copper to figure out what the theoretical yield is. So I'll give you guys a minute to work on that. And so I want to figure out how many grams of copper are produced theoretically so that I can determine my percent yield. And that's going to require a double stoich. So, and I know that because I have both reactants given to me. So with stoich, the first thing I need is a balanced chemical equation. And I have that. That was provided. So step 2 is convert the given units to moles. So I'm going to do that for both of my reactants. I'm going to convert both my reactants to moles. So how many grams of carbon to 1 mole of carbon, and how many grams of copper 1 oxide to moles of copper 1 oxide. So the grams of carbon, that's easy. I look on the periodic table, it's 12.01. What about the copper 1 oxide? Anybody calculate that?
I got 143 grams.
143 grams. Excellent. Thank you, Lauren. So that's step 2 of those stoich steps. Convert given units to moles. So we did that. Grams of copper cancel. I have moles of carbon. Grams of copper 1 oxide to moles of copper 1 oxide. And now step 3 is what?
Ratio.
Yes, convert the moles of the given to the moles that you want. So there is 1 mole of carbon to, I want 2 moles of copper. And there is 1 mole of copper 1 oxide to 2 moles of copper. So that's step 3. And step 4, convert the wanted moles to what? The units you want. And the units I'm comparing for actual is grams, so I might as well convert that to grams. So 1 mole of copper is it 63.55? Yeah. 63.55 grams of copper. And then 1 mole of copper is 63.55 grams of copper. And see, I don't even grab my calculator until I set it up because it's nice to see that this last half is exactly the same. So for the top one, what did you guys get for 11.5 grams of carbon?
121 grams of copper.
121 grams of copper. Does that look right to everybody? Looks good to me. I didn't calculate it, but I'm trusting you. And then what about the bottom one?
$101.
I would round that up to 108, but 108 grams of copper. So which one is the theoretical yield?
It would be the copper 1 oxide.
The copper 1 oxide is not the theoretical yield, it's the limiting reactant.
Oh,
But yes,
sorry. Yeah.
the copper 1 oxide is a limiting reactant. So what is the theoretical yield?
108 grams of copper.
So it's 108 grams of copper. And now what do I need to do to get percent yield?
Take the actual yield and divide it by the third. Yeah.
Yep, 87.4 divided by 108. The grams of copper cancel times 100. And what is that? It's going to be about 85-ish or so. Let's see. It's 3 sig figs, so 80.9% yield. So we see it was 101.7. Oh yeah, because sig figs is 4 here. That's okay. And then the theoretical. Oh, there. It was 101 point. Oh, that's odd. I got 108. Did you guys get 108?
I got 101.
Oh, so okay, that was my bad. So let me. You got 101?
Yeah.
So let me double check that. See, so it's good that you guys catch. You guys, you want to keep. You want to make sure that because I can make a careless mistake, right? Yeah, it's 101.8 or 0.7. So let me erase that. My bad. And then that would go there. Yeah, so it's 85.9.